OSPF is the most important routing protocol for the CCNA exam. It is an open standard link state protocol that powers enterprise network cores. Every OSPF router builds a complete map of the network and uses the shortest path first algorithm to calculate the best routes. Understanding OSPF is essential for both the exam and real-world networking. OSPF routers follow 3 steps. First, they form neighbor relationships. Second, they exchange routing information to build a network map. Third, they calculate the best routes. Routers exchange information using link state advertisements, or LSAs. Each router creates an LSA, describing its connected networks, and floods it to all routers in the OSPF area. Routers organize received LSAs in the Link State Database, or LSDB. All routers in the same area share an identical LSDB. OSPF divides large networks into areas. An area is a set of routers sharing the same LSDB. Multi-area OSPF uses a backbone area, Area 0, to which all non-backbone areas must connect. Multi-area designs reduce LSDB size, speed SPF calculations, and isolate network changes. OSPF defines 4 router types. An internal router has all interfaces in the same area. A backbone router has at least one interface in Area 0. An area border router connects areas to Area 0. An autonomous system boundary router connects OSPF to external networks. OSPF metric is called cost. A route cost is the cumulative cost of each outgoing interface along the path. Cost erodic. Link cost equals reference bandwidth divided by link bandwidth. The default reference bandwidth is 100 megabits per second. Results less than 1 become a cost of 1. This means links of 100 megabits per second or faster all have cost 1. A gigabit link and a 10 gigabit link are treated as equal. Fix this by adjusting the reference bandwidth with auto-cost reference bandwidth in OSPF router configuration mode. Use the same value on all routers to avoid routing loops. You can also set cost directly with the IP OSPF cost command in interface configuration mode, or modify the interface bandwidth value. The IP OSPF cost method is preferred because it does not affect quality of service. Create an OSPF process with router OSPF, followed by a process ID. The process ID is locally significant and does not need to match neighbors. The router ID, or RID, is a unique 32-bit value identifying the router. It is determined in this order. First, manual configuration with the router ID command. Second, the highest IP on an operational loopback interface. Third, the highest IP on an operational physical interface. A loopback interface is a virtual interface that is always up, providing a stable address for management and the ROD. Configure it with interface loopback number and assign an IP with a /32 net mask. Once the RID is selected, it persists even if you add a loopback interface. Change it with the router ID command and reset OSPF. Activate OSPF on interfaces using the network command with a wildcard mask, or the simpler IP OSPF process-ID area command in interface configuration mode. A passive interface is OSPF enabled but does not send hello messages. Use passive interfaces on end-user networks and loopback interfaces. Configure with passive interface in router configuration mode, or use passive interface default and then no passive interface for specific interfaces. To advertise a default route, configure a static default route on the ASBR, then use default information originate. The router must have a default route in its routing table first. OSPF uses 5 message types: hello for neighbor discovery and maintenance, database description for LSDB summaries, link state request to ask for specific LSAs, link state update to send LSAs, link state acknowledgement to confirm receipt. Routers progress through 7 neighbor states. Down means no hellos received. Init means a hello was received, but the local RID was not included. Two-way means both routers see each other. Xstart determines the exchange leader. Exchange sends database summaries. Loading requests and sends specific LSAs. Full means LSDBs are synchronized and the routers are fully adjacent. Hello messages are sent to multicast address 224.0.0.5. The default hello timer is 10 seconds, and the dead timer is 40 seconds. A neighbor is removed after 40 seconds without a hello. OSPF network types determine behavior on a segment. Broadcast is the default on Ethernet. Point-to-point is the default on serial links. Both use 10-second hello and 40-second dead timers. On broadcast networks, a designated router and backup designated router are elected in the two-way state. The DR and BDR form full adjacencies with all routers on the segment. D-routers only form full adjacencies with the DR and BDR, remaining in two-way with each other. This reduces adjacencies and OSPF traffic. DR and BDR election uses highest interface priority first, then highest RID. Default priority is 1. Set priority 0 to prevent a router from becoming DR or BDR. DR and BDR are non-preemptive. If the DR fails, the BDR immediately becomes DR, and a new BDR election follows. Force a new election by resetting OSPF with clear IP OSPF process. Point-to-point eliminates the DR and BDR election entirely. Two routers establish a full adjacency directly. Configure with IP OSPF network point-to-point on both sides of the link. For OSPF neighbor formation, several requirements must be met. Area number and subnet must match. OSPF process must not be shut down. RIDs must be unique. Hello and dead timers must match. Authentication settings must match. IPMTU must match, or routers get stuck in Xstart or Exchange. Network type must match, or routers establish adjacency but cannot synchronize, LSDBs. 3 LSA types are essential for the CCNA. Type 1, the router LSA, is generated by all routers and describes their links. Type 2, the network LSA, is generated by the DR on broadcast networks and lists all routers on the segment. Type 5, the AS external LSA, is generated by ASBRs and advertises external routes, such as a default route. View the LSDB with Show IP OSPF database. All routers in the area should show identical output. OSPF is the core routing protocol on the CCNA exam. It floods LSAs to build a complete network map, runs the SPF algorithm to calculate best routes, and uses structured neighbor formation to exchange information. Configure OSPF with the network command or IP OSPF area. Set the router ID. Use passive interfaces. Advertise default routes with default information originate. Understand DR and BDR election on broadcast networks and when to use point-to-point. Memorize the neighbor requirements and the 3 LSA types.